Hello friends, it's like Kizit here, and today I'm going to start a new course, that is wave and optics. Wave and optics. And we're gonna study this course in two parts. One is wave and the other is wave optics. Right. So hope you know that the branch of physics called optics that can be studied two ways. One is ray optics, another is wave optics. So here we're going to discuss about wave optics. And so today we're going to start with this topic, simple harmonic motion. Okay, so we're going to start this course with this topic, simple harmonic motion. Okay, so in order to explain this, let me clean the board. So in order to explain what is simple harmonic motion, let me consider a particle. This is moving in a circular path like this. Okay, this is moving in a circular path, right? Let me draw it properly. Okay, just wait, give me a second. So here you can see, so this is a particle and moving in this direction along this circular path, and let me take the radius of this circular path is suppose A. Let me take this radius as capital A. Okay, now you see, if you draw a perpendicular to the to y-axis from this point P, right? If you draw a perpendicular P, let me take this point M. Now when this is moving in this circular path, then this point M is oscillating up and down. Let me tell you why. Now you see, this is the y-axis and this is the point P here. Okay, this is the O and here is the radius A, and this is the perpendicular we have drawn. This is the point M. So when this P is here, when P is this point, okay, then this M will be here. When P comes here, then this point will be M. Then again, if P cross this point, if P comes here, then this M gonna come down, right? Similarly, if P comes to this position, then this perpendicular is also coming down, right? So with this circular motion of P, this point M is going up and down like this. Okay, when P will be here, then the perpendicular to the y-axis will be here. So now here this point M is coming down. So we can consider that this point M is oscillating about the origin, right? We can consider that way. Now let me clean this part, and now let me explain this motion. Okay, now let me assume that this point P was here at this position X when t is equal to 0. When t is equal to 0, the position of P is this. When t is equal to 0, right? At time t, and this is the position of P, right? At time t, this is the position of P, of the particle, right? Let me consider that way. Now let me take that this angle, suppose this is A, this angle is suppose theta, this angle is theta, this angle is theta. So if this is theta, this must be also theta, that is alternate interior angles, right? That is alternate interior angles. Now you see, let me consider that the angular speed of P is omega. So let me consider that particle P is moving in the circular path of radius A with constant angular speed. Omega, right? With constant angular speed omega. Now you see, then omega will be given by theta by t, right? So angle subtended by this arc, which is covered by this particle in time t, is theta, right? Angle subtended by this arc at the center after time t is theta. That's why angular speed will be given by theta by t. So that's why we can write theta is equal to omega t, right? Theta is equal to omega t. Now this OM, so OM, sorry, not OM, let me write PM. PM is the perpendicular to y-axis at M, right? At M, and OM, this OM gives the displacement of this particle along y-axis, right? So now you see, this particle P is moving in this curved path like this from here to there. This is P, now this is P. So what is the displacement along y-axis in this direction, right? Along y-axis is given by this part, right? So this is suppose origin O and this is the point M, right? So this is the displacement, vertical displacement, right? So that's why we can say, let me clean this part. So this OM is the vertical displacement of P. This OM is the vertical displacement of P, right? We can consider it way. Now you see, if we use the trigonometry, okay, if we use trigonometry from this triangle OPM, if you use trigonometry, this is theta, this is O, this is M, this is P. So now you see, we are to find this displacement. So with respect to this angle, we're going to take this as perpendicular, and we know this length, and this is going to be hypotenuse, which is opposite to 90 degree, right? And the relation between the hypotenuse and perpendicular is given by sine theta. So from this triangle we can write sine theta is equal to perpendicular OM by hypotenuse OP. So OM is unknown and OP is capital A, right? So that's why OM is equal to A sine theta, right? OM is equal to A sine theta. So that's why we're gonna get OM is equal to A sine theta. And let me consider this displacement along y-axis in time t. Let me represent it by yt. Let me represent this displacement y of t. Let me right here y of t, that means displacement along y-axis in time t. So then this is capital S sine theta. Theta is nothing but omega t, so we can write here omega t, right? And this is the displacement of the particle along y-axis. Now you see, let us find velocity. Okay, let us find velocity. So we know that time derivative of displacement gives the velocity, right? So let me write dy by dt, right? dy by dt. So if you differentiate it, then you're gonna get a derivative of sine is cos omega t, and this is function of function. Then you have to differentiate this omega t part again with respect to time t, then you're gonna get omega. If you differentiate this, you're gonna get omega. So let me write the omega here. Okay, omega a cos t. Let me write here omega a cos t. So this is what velocity. So this is what we have got. We have got velocity, right? dy by dt gives velocity. Now this cos omega t can be written as, now you see, let me write omega capital A. We know the relation between cos and sine is 1 minus, so this cos omega t can be written as root over 1 minus sine square omega t, right? We know this relation. And this capital A is the radius of radius of this circle, and which is also the amplitude of this particle. Amplitude means the maximum displacement from O. So here the maximum displacement which is possible from O is equal to A, because this is the radius. When it will rotate like this, then this length will be A, and this length is the maximum displacement from O to that point, right? Because this particle P follow this circular path, it not gonna travel outside this circular path. So this is the maximum displacement. So that is A. A represent the amplitude of this particle. Okay. So hope you have understood this. So now you see, from this relation, what you can write, this relation will give you sine omega t. Sine omega t is y by a. Sine omega t is y by a, right? From this relation, if you put here, if you put this relation here, if you put this value of sine omega t, that is y by a here, then what you gonna have? Then you will get dy by dt, which is velocity, right? dy by dt is equal to omega a root over 1 minus y square by a square. That's what you will have, right? Now if you put this a under the square root, then it becomes this a becomes a square, like this, a square into 1 minus y square by a square. Now if you multiply these two, then a square into 1 a square, and if you multiply here a square, then a square will be cancelled. So here we're going to get this expression. So this is the velocity of this particle, right? This is the velocity v, right? Hope you have understood this. Then what going to be the acceleration? So let me write these things again. Let me clean this board. Okay, I'm going to write this expression here just at the top of the board. So let me pause the video. Just wait. So now let us find the acceleration. Okay, now let me tell you one more thing. Sometimes in different books used different symbols. Instead of capital A, sometime different author may use small a as well. Okay, don't be confused with that. So now, okay, acceleration A. So as I am using acceleration A is small a, that's why I am using using capital A to represent amplitude. Okay, so here A is nothing but dv by dt. Okay, dv by dt, right? So dv, this v is nothing but dy by dt, right? And dy by dt, what we had got from this displacement dy by dt, we had got that omega a cos omega t, right? So in order to find the acceleration, let us differentiate this again with respect to t, right? So if you put here and if you differentiate it, then what you're gonna get? So we know derivative of cos is minus sine, so here we're gonna get minus omega a sine omega t, and this is function of function. Again you have to differentiate this, then one more omega comes out, so that's why it will omega square. So what we have got, acceleration is equal to, that is minus omega square a sine omega t. That is what we have got, right? Now you see, from this relation sine omega t, we know that y is equal to a sine omega t. From this relation sine omega t is equal to y by a, right? Is equal to y by a. So here we can write minus omega square a into y by a. So here a cancels, so we have got omega square y a. So now you see, this negative sign represents that this acceleration is towards the mean position, that means the origin here. So here you see, this is the origin, this point M. When the point P is moving this way in this direction, this M is going up like this, right? And the acceleration is towards this direction. This is y dash, which is negative direction, this is positive direction, right? Positive y-axis, negative y-axis. So when a is positive, that means when this point P will be P point to reach this point, then maximum amplitude, that is a. So a is positive. When a is positive, then a is equal to minus omega square y, right? And when a will be negative, then this is going to be positive, right? So hope you have understood this. So now let me clean these things. Okay, from this relation we have seen that acceleration is proportional to the displacement. Acceleration is proportional to the displacement. So acceleration is proportional to displacement. And direction of acceleration is towards the mean position, and the direction of acceleration is towards the mean position. Okay, towards the mean position means for this point M, which is going up and coming down, that means it is oscillating about this origin. this point M, which is oscillating about this origin, right? So that means when t is equal to 0, when this point this particle P is at this point, right, at this position, the OM this M must be at O, right? When this particle is on x-axis, when t is equal to 0, this M is this M must coincide O. That means at t is equal to 0, when this P was at rest. So this position is mean position for this M, right? So hope you have understood this. Now such kind of motion where acceleration is, you know, directly proportional to displacement, acceleration is proportional to displacement, and the direction of acceleration is towards the mean position. Such type of motion is called simple harmonic motion. So how to define simple harmonic motion? Okay, a particle is said to be, or an object is said to be in simple harmonic motion if its acceleration is proportional to displacement and it is acting towards the mean position. So here let me write the definition. A particle or an object is said to be in simple harmonic motion if its acceleration is directly proportional to let me clean this, is directly proportional to displacement and directed towards the mean position. Directed towards the mean position. Right. So this is the definition of simple harmonic motion. Right. A particle or an object is said to be in simple harmonic motion if its acceleration is proportional to the displacement and it is directed towards the mean position. Okay, the acceleration must be directed towards mean position. So hope you have understood this. So note these things and let me clean the board and let me analyze this motion, okay, in details. Let me analyze the motion of this particle. Now you see, when this angle theta, just wait, let me make this. So right, now you see, when this angle theta is equal to 0 degree, that means the particle P is at this position at x. Okay, so I am considering this is x-axis, also I am considering this point is also x. Let me take that way. Okay, instead of giving another name, let me take that point x, that is y, that is x dash, and that is y dash. Okay, so hope you got it. So now position is now x dash, right? So at this position, so displacement of this, now when this point P is at this position, this OM coincide with OP. Sorry, not OM, this MP coincide with OP, right? So length of this OM, that's going to be 0. So here, displacement, that is why this is displacement. In this case, displacement is 0, right? And here you see velocity, that is V. In this case, velocity V. So when y is equal to 0, the velocity will be, if you put 0 here, omega root over a square means omega a, right? Omega a. So as p is moving in this direction, the velocity will be directed upward, so it will be positive, right? Acceleration, that is a acceleration. So when the p is at this position, acceleration, so y is equal to 0, so if you put 0 here, acceleration will be equal to 0. Now if the theta, now consider this p at this position. When p is at this position, that means m reaches this maximum height, which is equal to the radius of this circular part, that is a. So that means when theta is equal to pi by 2, at this position, here theta is equal to pi by 2, so position is y, and sorry, this should not be x dash, this is x, okay? When the p is here, that is x, not x dash, okay? So sorry for the mistake. And when theta is equal to pi by 2, that y is equal to, sorry, not y is equal to, position is at y, and the displacement will be equal to its radius and the velocity. When y is equal to a, that a square minus a square, that's going to be 0, right? So you can compare with this, if an object is thrown vertically upward at the maximum height, when it reaches the maximum height, it is going this way, and just before it starts to falling down, its velocity becomes 0, then again it is increasing downward, right? So at the maximum height, when m reaches there, then the velocity will be 0, and acceleration will be maximum. That when m goes up, the acceleration is acting downward, so that's why it will be minus. What will be the acceleration? If you put y is equal to a here, then acceleration will be minus omega square a, right? So similarly, when this angle theta, is now pi, this angle is pi, that means the point p is at this position here, this angle is pi, from this position to this position, right? From this one to this is pi. So let me write with the black ink, this is pi, then the particle is at x dash, now it is x dash, okay? And displacement is again 0. So that means when the particle p is here, the perpendicular on the y-axis is this, and then m comes to this origin O, so that means OM is equal to 0, so that means displacement equal to 0, and velocity, now m is coming downward, right? So that's going to be negative omega a. When y is equal to 0, velocity is omega a, because square root of a square will be a, so but it is now directed towards negative y-axis, it is coming along negative y-axis, so it is directed towards downward, so that's why negative. And the acceleration at this position, okay, when the point when this m is here, then acceleration is again 0. At mean position, acceleration is always 0, right? And when again this p comes to this position where 3 pi by 2, the theta is 3 pi by 2, so let me draw this. When the theta is 3 pi by 2, then it is at y dash, then acceleration, sorry, not acceleration, displacement. Now in this case, this will be the displacement which is maximum, but in negative direction, so minus a, and the velocity will be again here at this position. At extreme point, velocity will be again equal to 0, and acceleration, this time acceleration is in this direction, which is positive. So, and y is equal to minus a. If you put here minus a minus minus, it becomes plus. So here we're going to get positive omega a square, right? Again if you take 2 pi, then again you're going to get these results, because after after completing one cycle, the one cycle, that is 2 pi, the particle will be at this position again, right? So hope you have understood this. So now if you want to write this, then pause the video, note it here. This omega square is equal to a by y. So here I am not taking the minus sign, because you see omega is the angular speed, and this minus sign occurs due to the direction, because of direction, right? So here we don't need this minus sign in this case. So omega is equal to root over this. So you can write omega is equal to, that means amplitude, sorry, acceleration, not amplitude, acceleration divided by displacement. Right? You can write this. Okay. Now you see, if t is the time period, time period means the time taken by this particle to complete one circular motion, and then angular displacement will be given by 2 pi, right? So in time capital D, it completes 2 pi, right? The angle subtended by this complete circle at the center is 2 pi. So in that case, omega is equal to 2 pi by t. So in time t, if it completes one cycle, then that will be 2 pi by t. And we also know that one more thing, that 2 pi into 1 by t, 1 by t is nothing but 1 by t is the frequency, that is number of complete oscillations in 1 second. Okay, so that is omega is equal to 2 pi nu. Okay, 2 pi nu, right? Now you see here, these are very important relations, so you should remember this. Now you see, let me I'm trying to establish a relation between this and that. So if you compare these two equations, then what you're gonna have, then you're gonna have from this relation we can write 1 by omega is equal to root over displacement by acceleration, we can write that, and this is written as root over k. Okay, root over k, right? Now let me clean this, sorry. Now you see, so 1 by omega is equal to root k, 1 by omega is equal to root over k, and omega is equal to 2 pi by t. So 1 by omega, that's going to be t by 2 pi is equal to k, and so here t gives 2 pi root over k, where k is equal to this displacement by acceleration, right? Hope you have understood this. Okay, and now you see, here we have considered that When t is equal to 0, p is at this position. What if this p started moving from other point, okay, not from this point? So let me tell you, let me explain how. If p starts from here, then this equation of displacement y is equal to given by a sine omega t, right? Now if you see, let me take this situation. Let me take this situation. This is the circular part. Suppose this particle p is start moving from this position when t is equal to 0. When t is equal to 0, so when t is equal to 0, this angle is suppose alpha. This angle is suppose alpha. This angle is suppose alpha. Now after time t seconds, it reaches this position, okay, from this point to this point, okay, at t, when it is at t. So now this angle will be equal to omega t, not this whole angle, this one, because this is at t is equal to 0, from t is equal to 0 to t is equal to t. So this angle is omega t, right? This angle is omega t. So in this case, instead of omega, right, so that means now in this case this theta is equal to now, this theta is equal to now omega t plus alpha, right? So this equation comes from this relation, right? Y is equal to a sine theta, and when theta is equal to omega by t, then we get this relation. For this case, you know, theta is equal to this one, so here we're gonna get y is equal to a sine omega t plus phi, okay, omega t plus phi. This is called initial phase, right? Now what if this p starts moving from this position? This is x, this is the circular path from this position when t is equal to 0, right? And at t is equal to t, this is the position, suppose, right? Then here you see this angle is, now we're going to take this angle as minus alpha, okay? In clockwise direction we take negative, and in anti-clockwise direction we take positive, and this angle is now omega t, right? Omega t, right? Now here you see, in this case, sorry, not omega t, sorry, now omega t is this one, sorry, this angle is alpha, right? This angle is alpha, okay, let me write it properly. This angle is alpha, and this angle is now, this angle is omega t, because here t is equal to 0, the particle is at this position when t is equal to 0, and it takes time t to reach this position, okay? So that's why this angle must be omega t, right? And this angle is suppose alpha, this angle is suppose alpha. Now you see, when we find this displacement, this angle is always measured from this positive x-axis, okay? This angle is this angle should be measured from this point, right, from this positive x-axis. So when we have measured from positive x-axis, in this case we have taken omega plus alpha, here omega t plus alpha, and here you see, to measure this angle from this position, what will be the angle between this x-axis and this radius? So this angle minus here is, you see, omega t, this angle minus this alpha, right? So this angle, here you see, angle between this x-axis and this radius, that means this line joining p and the origin O, this angle is now omega t minus alpha. So in that case, in this case, here the equation, in this case, this equation y will be equal to a sine omega t minus alpha, right? So just remember this way. So if this angle is plus alpha, this angle should be taken as minus alpha, right? So hope you have understood this. So pause the video and hope you have understood this. Thank you for watching. See you in the next video. If you like my videos, do share with your friends. Inspire me to create new contents for you and help me to grow my channel. So see you in the next lecture. Bye bye.